Hello astronomers, welcome to my exotic tutorial for you that are having problems. This should work if you have a home computer and you have a personal Gmail account. If it doesn't, just try using a different computer. Usually home laptops work, home desktops, whatever. But you have to have a Google account and you have to have your own computer, from what I know. So if you can find workarounds, that's great. Let us know. But this is the procedure for now. So first, you're going to want to clone a dataset. In Discord, I have them posted as Google Drive links, so you're just going to have to copy them and then put them in your own drive. Right here, I have all these folders with all of my data in my Drive Exotic folder. So we'll just click on one of these. Let's say P59. This is a good data set. So I have all my data, all these images stored in my drive exotic P59 data. So we're gonna have to memorize that, or you can just look back if you want. So the first thing we're gonna do in exotic, this is posted in Discord, this link, but you can also find it on NASA's website. If you have trouble with it, let me know. We are going to first click on Mount Google Drive and load exotic libraries. So this might take a while, but you're just gonna have to wait for it, and it's gonna ask you to access your Google Drive files because it needs to access the files, obviously. Now you won't have to go through all of this if you're running it locally, but running it locally does take a little bit more technical knowledge. If you are interested in that though, let me know, because it does go way, way, way faster, and it's not as much of a hassle, especially with all the Google account stuff. But you still might need your own computer, because I don't know if the school laptops will allow you to run Python code natively. So it didn't ask me now, but usually asks you like, do you want to access your drive? And then you're just gonna have to allow it permission. But because right here I already allowed it. So yeah, there we go. So it finished. We have all these libraries imported. And the next step is just to load the telescope images. So we have to input the Google Drive file path here. And in my case, I don't know how it is with yours, you're just gonna have to figure it out. But for example, mine is my drive exotic P59 data. So in here, I'm just gonna leave out the my drive and I'm gonna put exotic P59 data. Okay. And then you separate all those folders with forward slashes. Now this next section is if you're registered with the AAVSO, which is a service that we use to upload our data to NASA. So if you don't worry about it, but you should if you want to upload this to repositories. So here I'm just going to put mine, but it is optional, don't worry about it. So the next is the object name. Since this is P59, the object name is just going to be P59B. The formatting here is a little weird. It might deny your name if you don't format it correctly. So usually just adding little hyphens here and there will work between the letters and numbers. So I'm going to run this now, and it's going to found 126 image files. There we go. Now it's going to load them. It searched the exoplanet archive, and now we have all these parameters for analyzation, along with the images, which are our primary source. So yeah, now everything is loaded. So the next step is to identify the target star and the comparison stars. So telescope, we're just going to select micro observatory because it's pretty close to Borealis, and we're going to input the name of our star. So like it says here, just omit the B or other trailing letter. So if P32b is the exoplanet, P32 is the star. So in this case, our star is P59. And then we're going to run it. So, okay, so sorry guys. The star chart generation failed. It looks like, which does sometimes happen. I'll admit this isn't perfect, but usually it will work. It's just that Happy 59 is a recently discovered star, so it's iffy. So what you're going to want to do in this case is just go to NASA Exoplanet Archive. This is the link, Exoplanet Archive, IPAC, Caltech edu. And what you're going to want to do is just paste in the RA and DEC into the variable star plotter. So that's RA, right ascension, DEC, into declination. And this is apps a VSO or /VSP. If it fails, it'll give you this link right here, use the advanced search. So you can just use that. And then you're just going to want to plot chart. And it will generate. Oh, wait. Okay, wait, hold on. Okay, so we're just gonna have to put this into a different format, which is fine. You gotta do this stuff sometimes. Units are annoying. Okay, so let's regenerate it. And it gives us a thing. Wow. So you're just going to want to click on it, and then you'll paste this link, and you can just paste it into here. So it will generate the star chart. There we go, finally. And boom. Wow, that is big. So it'll give you this. It'll give you your star field right here. So this is one of the images from the telescope, and this is the star chart. So this is the really hard part. You just need to find where this star is in the crosshair in your actual pictures. So the way I like to do it is you look at these big stars. It looks like there's two kind of like this and two kind of like this, like making a trapezoid right here with two stars in the middle of each line. So we'll look for that here, and look, we found it. So I'm going to zoom in. Wait, not that much. No, not that much. Okay. Okay. So look, two close stars, two far stars, and then there's this one at the top. So too close, too far, and then there's this one at the top. So this is our target star. So you're going to want to hover over it, and then you're just going to want to find the maximum value right there, because that's the brightness of the pixel. So that's like really where the star is. So this is at X 588 and Y 415. So we're just going to go in here and put 588 415. We'll press enter, and then it will load for the comparison stars. So comparison stars are what we use to tell if the entire star field is being affected by some residual like clouds or sky glow. So it helps clean the data if we have a comparison. So we'll just select one of these really bright ones right here, because these are really convenient. So because you generally want to have a bright star that's really close to the target star. So we're going to use this one, 625 373. 625 373. And then you're going to want to make multiple brackets right here in this form, because we have to input multiple comparison stars. So look for another one, 674 441. I usually like to put 4 or 3. That's our target star right there. So let's zoom in on this area. This one looks good. So 526, 455. This one looks good. 491, 274. And boom. So that's our data set with all the coordinates of our comparison stars. Then we'll press enter. So that will create a inits JSON, and that will tell the program what to do when we actually run the program. So it's asking me what my elevation is here. Sometimes this happens, don't worry about it. I think the approximate elevation of Visalia is 100 meters. Let me check that. $101. Okay, so we'll just put 101 here. And boom. So that's it. And now we can just run Exotic, and it will do everything for us. But it's going to take a very long time, so you guys got to be patient. Don't close this window, okay? I'm not going to record this whole thing, because it'll take like, sometimes it takes 10, sometimes 20 minutes. But sometimes it asks you things in the beginning, so I'll go through those, but then we're just going to cut to the end, because it doesn't really ask you for anything else. So we're updating our server file list. These servers went down during the government shutdown, which is why Exotic didn't work, because they need to pull ephemeris data from servers to figure out like where the star would be in the sky at your time in your location, so it can account for the mass of the atmosphere that you're looking through. We call that air mass. And then it can normalize with air mass, so the light curve is more consistent and flat, except for the transit, of course. So we're downloading our files now. Sometimes it asks you for that, but you can just say yes if you want. All right, we're just gonna skip. And here Exotic has run, so we have all this output. It removed one of the variable stars from our comparison list, so that's good. You can see all the output right here. This is fitting the light curve, quality okay. Then it shortened the uncertainties. You can see as it progresses and iterates. All right. So here's the final light curve. It's not great, but it was a noisy data set. It's kind of fine. There's some interference, I think, like right here. This is the actual baseline, so it would go something like this in reality. But this was a pretty good data set. So you can submit it to AAVSO, and they'll integrate it with the rest of their data sets, and we'll get a better reading on what this planet is actually doing. So you are contributing to science, don't worry. This is a triangle plot. The more circular this plot is, the more certain it is that you've detected the planet. So this is a pretty good reading, although there is some interference. You can see all these results in basically just the input folder that you put with underscore output at the end. So exotic happy 59 data, but then there's also data underscore output. So yeah, these are all the files. We got light curve, temp. You can look at image files, sample files, raw flux. This is unadjusted, so you can, it's kind of curved here, but you can see the transit like just happening right there. But you know, that's without normalization, so it looks a little curvy sometimes. Centroid positions. It's basically just measures how stable the telescope was during the data collection. So we can see it was pretty stable, then it kind of wobbled out of control here. It does that sometimes, but I'm doing my best to stop it. Observing statistics over like each integration triangle plot right here. This is the text file, AVSO blah 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 .txt. This is what you'll upload to AVSO. This is the data they'll be using at NASA. So they have thousands of data sets like this. Not thousands. Usually the targets that I'll give you, they have like 1 or 2. So you'll be really giving them help on what they're seeing here. But you'll upload this. I'll make a video on that later to AVSO so that NASA can use it. Let me know if you need a tutorial for that. If you want, you can generate a certificate. You can put your name in and run it. These are kind of cute. I don't know. You'll probably be doing a lot of these, so these certificates aren't really like official or anything, but you can show them to your parents and they'll be proud of you. And it's kind of cool. So yeah, that's EXOTIC. Thanks, guys. Bye-bye.